Hi guys, welcome back to the video series on blockchain oracles. So this is the fourth video, and in this one we'll go through another demo of using Chainlink oracles. In the past video we have gone through a demo where we were using Chainlink for fetching the price feed data. And in this one we have another use case which is random number generation. Use cases in which we'll use random numbers are for building blockchain games, NFTs, for any task that requires you to assign a random person, or you want randomness is where random numbers comes into picture. We have seen folks trying to generate random numbers in the smart contract using block timestamp, block hash, but all of those methods are not secure. They can be influenced or they can be manipulated by the validators or miners. So the correct way and the recommended way to use random numbers in smart contracts is using oracles. And in this one, we'll walk through the verifiable random functions in Chainlink. So let's get started. So this is the Chainlink documentation that I have opened. If you see here, we have this option of VRF. VRF stands for Verifiable Random Function, and it says it's a tamper-proof random number generator. So let's click on it, and so for every request that we send, Chainlink VRF generates one or more random values, and there is a cryptographic proof of how these values are determined. Then this proof is published and verified on chain before anybody can use it. So what this means is the proof that we have on chain makes sure that the random number generator results cannot be tampered or they cannot be manipulated by anybody. So this really provides us random numbers which are secure. So if you see, Chainlink has something called VRF v2.5, and it has all the benefits of V2 and it has some additional benefits. So one of the benefits is now we have an option to pay for request in either the link token, which is the token for Chainlink, or the native token of the blockchain that we are working with. So in this case, since we'll be working with Ethereum, the native token will be ETH. If you want to use Chainlink VRF, there are two methods that you can use to request randomness. So one is the subscription based and the second is the direct funding. So what happens in subscription based is you create a subscription account and then you add balances to it. And this subscription account, a single subscription account, can be connected to multiple consumer contracts. So whenever a consumer contract requests for a random number, once the request is fulfilled, the transaction cost is calculated after it and the balance is deducted from the subscription account. This method, as in using the subscription, allows us to fund requests for multiple smart contracts from a single subscription. And the other way to do is through direct funding. Let's say you have a smart contract, you directly pay via the link token or the native token whenever you want to request a random value. Now you might be wondering, okay, we have these two methods, which should we choose? So the documentation tells you how you can select one among them. So I'll touch upon some of the differences between these two, as both of these supports the latest VRF version, which is 2.5 as of October 2024. And subscription method is useful when you want to generate random numbers regularly. Let's say you want to generate random number only once or twice, then go ahead and work with direct funding. The other thing is, since the subscription account is connected to multiple contracts, that's what makes the overall gas cost reduce. Whereas in the case of direct funding, each VRF consuming contract pays directly for its request. And in the case of subscription method, the cost is calculated after requests are fulfilled. But in the case of direct funding, when you make a request, at that time the cost is estimated and charged. If you want to use direct funding, you don't really need a subscription account, but for subscription method, you require a subscription account. And then one more important thing to call out is in a subscription method, in one request, you can get multiple or like more random values. And in the case of direct funding, you will get fewer random values for one request, which is usually lesser than the subscription method. For this demo video, we'll stick to the subscription method. So now let's move on again. Now I'll touch upon how is this VRF different from the price feed that we have used. So in the price feed example, if you remember, when we were trying to fetch the price feed data, the data was being stored in the contract. It was like a reference data, and it was being stored until the Oracle updates it again. So you can just get the data from the contract. Whereas in the case of randomness, it cannot be a reference data. Reason being, let's say if you're storing the random function result on chain, anybody can predict the outcome. So randomness is requested from an oracle which generates a number and a proof. Then the oracle returns the result to the contract. This is known as request and receive cycle. And then the contract needs to do whatever it wants to do immediately with those results. Otherwise, it will get stored, which will like defeat the purpose and which won't make the random number secure. Let's get to the building part quickly. So if you see here, that we will be using the subscription one. And in the case of subscription also, there are two ways you can do it. One is you can actually use the VRF subscription manager, right? And then the other is, if you want, you can create and manage subscriptions programmatically. But for this demo, I'll stick to using the subscription manager. So the rest of the document that you see is something that we'll do live. So let's head over to the VRF subscription manager. So manager will have a subscription ID and it can connect to multiple contracts, and these contracts are identified by the address at which they are deployed. So I'll show you how it is done. Let's click on create subscription. Here, if you have noticed, the Ethereum Sepolia network, and this is the wallet which is connected. I'll click on create subscription. So here I'm trying to create a subscription which will have an ID, and this is the ID which I'll use in my smart contract when requesting for a random value, and you'll understand all of it better when we get to the smart contract part. So this is my wallet address and this is the admin. So I'll go and click on create subscription. But before that, I want to walk you through some of the steps. So this is the first step where we're creating a subscription. Then what you'll do is you will add funds to the subscription and then you will add consumers. So let's click on create subscription. So if you see, it says I need to approve the subscription creation. I got this MetaMask pop-up. I'll click on confirm. Okay, it says my transaction is pending. Okay, one more thing to note is if you want to play around in the Sepolia testnet, you need to have Sepolia ETH in your account, which I already have. If you don't have, feel free to go to any of the faucets and get Sepolia ETH from it. So I'll still click on the transaction hash. So it says it's success. So basically saying that I am the owner of this subscription. So I'll click on confirm. And if you see, woohoo, the subscription has been created. Okay, At this point, I won't be adding funds or anything. I'll come to it later. Now, if you see, there's something called a subscription consumer contract. So this is the example that we'll use for the demo. So let's just click on open in Remix. It will open the source code for you in the Remix IDE. And again, if you see here, this is the contract that we were talking about. Now, I'll walk you guys through this contract so you understand what's going on. There are certain libraries are being imported for the VRF and certain events are being emitted here. And then we have a structure called request status where we are keeping a track of random words and whether that particular request is being fulfilled or whether the request ID exists or not. And then we are having this mapping called sRequest, which is here we are mapping a request ID with a request status, right? And request status is this whole struct. And then we have a subscription ID. If you want to see what's your subscription ID, you have to go back to the VRF and click on the ID. And here this is the subscription ID. So this is the smart contract needs this to be able to connect with the subscription manager. And these two fields are the past request IDs. Okay, so this is like a very important concept. So this is a key hash. What it means is this is the maximum gas price that this contract is willing to pay for requesting a random number, and this is the key hash that is for the Sepolia network. So we will leave it as it is, but depending on the chain you are interacting with, you may need to change it. Then there's this state variable called callback gas limit. Remember, the consumer will send a request and then the oracle will get the result and send a response back, right? So the response is being sent through fulfillRandomWords. So it depends on the number of requesting values. So let's say if you are not able to do anything with those values immediately, you may want to store it. And storing each word will cost some gas. So this is the limit for the gas in the case you want to store the values. This request confirmations is kept by default to 3 for Sepolia. What it means is these are the number of blocks that will be confirmed for the number to be called valid. What it means is, let's say if this block confirmation is higher, it will take us more time, but the result will be secure. If we keep this to a lower number, then it will be faster, but the result may not be secure because the chain hasn't increased a lot. So other field is this num words, which is basically the number of random values you are requesting for. So here we are requesting for 2 random values. And this is the constructor that will be called when we deploy the smart contract. It requires a subscription ID. This is the subscription ID of the subscription manager that we have. And we're initializing it in the constructor to save another function call. And here is the function for requesting random words. So before running this function, the assumption is the subscription is funded because it will be going to use some funds. And here if you see, we have this parameter called enable native payment. So if you set it to true, you will use ETH in the case of Sepolia. If you set it to false, you will use link as the payment method. And this will basically return a request ID, which helps in identifying a particular request. So this is how we are doing it. We are using this coordinator, which role is to coordinate. And this is the function that we are using. And then request ID to request status mapping, we are storing all these things. And we are saying fulfill to false because as of now we are just requesting. We're saying exist to true because the particular request ID has been created for us. Now there is no random words, it's all zero. And we are pushing this in the past request IDs array that we created. And once all of it is done, we are emitting an event called request sent. Then we have a function called fulfillRandomWords, which requires you to pass the request ID and the random words. So this is basically updating the mapping that we have. It's setting it the fulfill to true. It's updating the random words. Then it's emitting this event called request fulfilled. This is for checking the request status. So here we'll pass the request ID and it will basically return if the request is fulfilled or not. So this is how the contract looks like. I'll take a step back and walk you guys over the architecture or the flow for the VR function. If you go to learn, there's this section on introduction to subscription, and this shows us the request and receive data. So this is like a diagram that will help you in understanding the life cycle of the whole subscription request. There's this EOA, which is externally owned account. This account is the wallet that you and I own, which is having a private key. So the first set of flow is for the user subscription management. So the EOA account connects to the subscription manager and then it adds a consumer, which we'll see in some time. So how that is done is through the VRF coordinator. VRF coordinator is like a smart contract that is doing all this stuff. And then once the consumer is added, we will fund the VRF subscription. Now the second set of flow is you and I will interact with this consuming contract. So we need gas for doing it. You and I call this contract through remits, and then we'll call this requestRandomWords function, which in turn will call the VRF coordinator. We just saw that function getting called from the VRF coordinator, which in turn will emit the event called request sent, and this event is being sent, and then there is a VRF service which is running, which is like off-chain service, which listens for events from the blockchain, and then the service respond with the response and the gas data. Then again the coordinator tries to fulfill random words and return it back to the consuming contract. So at this point, like if you see, we can either use link or we can either use the native gas token. So this is how the overall diagram looks like. Now you understand the request and the response flow, and we have walked through the source code as well. So now let's see it live. Let's go to the Solidity compiler section. I'll compile this contract. So it compiles successfully. And then let's go to this deploy tab. I'll select the environment as injected provider MetaMask. If you remember, we were talking about the subscription ID. Right, so let's switch back to where we left. So this was the subscription ID that we created, right? So let's click on it and we'll copy the subscription ID from here, put it over the deploy and deploy. It's asking for us to confirm the transaction for contract deployment. And now the contract deployment status is pending. On testnet, it could be slightly slow. So let's just wait. Okay, now it has been confirmed and it has been deployed. So, okay. So now the subscription manager's ID is tied with the contract. But we need a way for the subscription manager to know, okay, this is the consuming contract that is supposed to be requesting random values from you. Otherwise, anybody will be able to use our subscription as it is, right? Copy this contract address and then we'll go to the subscription manager. We'll click on add consumer. We'll click on add consumer. It wants us to confirm the transaction. We click on confirm. This has given us a transaction hash. Okay, let's wait for this transaction to be successful. Okay, so this says the transaction is success. Okay, so the consumer has been added, and here we can have more than one consumer, and that's the best part of using the subscription manager. I'll close this, and if you see here, the subscription is active. It says zero consumer. Let me refresh this page. Okay, sometimes this could take a little longer for the correct data to be updated. But you see a consumer here, right? And now it's time to fund the subscription if you want to request for a random number. So I'll click on fund subscription. I'll send, and this is the wallet balance that we have, right? The MetaMask wallet. So I'll send like 10 link here. I'll click on fund subscription. It's asking me to approve. I'll click confirm. And here we are trying to send 10 link from my wallet to the subscription account. So in V2.5, it's up to us how we want to pay for a request. We can either pay using link or we can either pay using the ETH. Okay, so it says 10 link has been added to a subscription. I'll click on close and the balance should ideally reflect here. I think it will take some time to update the details. In the meantime, let's go back to the remix. This is the deployed contracts that we had. And if you see here, these are the methods, the functions, and the variables. So I'll click on the owner, and this is the owner for the contract. And if we click on owner, this is our address because we are the owner for this contract. And then we have other variables called key hash. Last request ID is 0 because we didn't make a request yet. The number of words that this contract will return for random values is 2 for one request. And this is the subscription ID. This is the VRF coordinator for the Sapolia network. The request confirmation that we saw earlier is 3 blocks. And then you can just play around. Okay guys, so after giving it some time, if you come back to the subscription manager, here you can see our subscription ID and the number of consumers has been updated and the balance has been updated. So now we are ready to call the smart contract function. So let's go back to Remix. I wish to call this function called requestRandomWords, and I wish to pay in the link token. So if you see here, if you want to pay in link token, you will set the Boolean flag to false. So let's set it to false, click on requestRandomWords, and here if you see it says the transaction is pending. I clicked on confirm. Okay, the transaction went through successfully. If I click on last request ID, this is the request ID that gets generated. So if you see here, the transaction that we had for request random words, we could see success on Remix, but and also on the Ether scan, but it seems it's still pending on the subscription manager. So let's wait for some. Hi guys. So after spending some time, I got to know that the transactions that were in pending state was due to the fact that somehow it was not having the required tokens needed for the transaction to be executed, which is kind of weird because in first place I allocated 10 link, which was sufficient for the transaction to go through, but I could see the status saying pending for couple of hours. So after some trial and error, I added some more link, which I feel wasn't required, but adding the links helped me in getting that request random words transaction go through. So that's a learning that I want to share with you all. And then if you see here, it says transaction is pending due to low balance. So this error message is very useful for debugging. So if you see here, the maximum cost was predicted to be 0.03 ETH, but the balance is 0 ETH. That's why the projected balance is in negative. And in this case, if you might be wondering what we are trying to do, if you click on the transaction hash, the ether scan, and here if you see we're trying to request for random words. And the catch was in this case, we were trying with native payment as true. So we wanted to pay in ETH and we didn't have any ETH. So that's how we landed up in such a state. Couple of things I found which were glitchy was even though you deploy the smart contract via remix and then you add the consumer in the subscription manager, if you try to interact with the functions, sometimes it doesn't give you any response. So if you see, in my case, if I click on numWords, which is just a state variable, right? It doesn't give me any response. So to tackle this, I thought maybe we can skip remix and try to interact with the smart contract through other means. So I came up with the solution of using cast CLI. So let me walk you briefly about what is cast CLI. So now let's talk about cast CLI that we will use to show the demo. So cast CLI is a command line utility tool that is part of Foundry, and Foundry is a smart contract development tool chain. So basically you can use Foundry for compiling, running tests, deploying and interacting, and basically everything that you need to do with your smart contract management stuff. So Foundry has some tools. One of the most popular is Forge. It also has a tool called Cast. So if you see, Cast is being used to perform Ethereum RPC calls, and we just use the command line for it. So basically you can use Cast to send transaction or to make a smart contract call, everything from your CLI. So if you want to learn more about Cast, how you do it is you install Foundry, and then Foundry comes pre-built with this binary called Cast, and then you can simply type Cast help. It will give you all the commands that the Cast can support, and they have also given this example of using Cast. So that's pretty much about Cast. One more thing to note here is if you see the smart contract that we were using for subscription consumer, it had this request random words method, which was external and only owner can call this. And then there was this one method which was internal, which is fulfill random words, which is why we don't see it over here on the remix. And fulfill random words is something which is internal and we don't need to call it as user. So if you see the request and receive data, just to give a high level glimpse of it, if you see here, once the event is emitted and then this VRF service listens to it and responds. So basically, we are waiting for n number of blocks before responding. And once we get the event from the blockchain, this VRF coordinator is the one that will internally call this fulfill random words, right? So we don't have to do anything. It is something that will be taken care of by the VRF coordinator. And the other thing is this is the function that will use get request status. passing the request ID, and this in turn will return us whether the request is fulfilled and what random words has been generated. So enough of talking, let's see the demo via cast. So for using cast, you can use any terminal of your choice and you have to install Foundry, and cast comes pre-built in it. And in my case, I've already installed Foundry. So if I do cast dash dash help, I'll get the help section for the cast, and it says it's for performing Ethereum RPC calls from the CLI. So we will be using two commands. One is the call, which is important, which is to make a call without publishing a transaction. This is basically for viewing purpose. And then we have a command called send, which is to sign and publish a transaction. Let's see what we need if I want to use cast call. So if I want to use cast call, these are the things I need. I need options, which is optional. I need the destination of the transaction. I need the signature of the function to call and the arguments for the function. We also need the RPC URL in the deployed contract section. I'll copy the address of the contract that is deployed, and then let's go to the subscription manager. The address starts with 60, so this is the address. If you see here, I have requested for random words thrice already, so I won't be using the cast to send another request. What we'll do is we will directly get the request status, and for that we have this method called get request status. We need to pass in the request ID, and request ID is something that we can get from the state variables. So first of all, we'll call this last request ID state variable, get the request ID, and then use it in the get request status. So let me export the required variables. So for the cast call, we just need the RPC URL because we are not publishing a transaction, right? So we don't need the private key in that case. And we also need the contract address. So I'll export the contract address. Okay. And then we'll export the RPC URL. This is something that you can get easily from the websites like Chainlink. Now let's make a call. So this is how we'll use the cast here. And if you see, I got the request ID. So this is what we'll use in getting the request status. I directly search Sapolia ETH RPC, and this redirects me here. If you see here, I'll use any of the address. So let me copy this. The earlier one should work ideally, but I'm not very sure what's happening. So, okay. Now let's run the directly use it over here. Okay, I think I got the issue. So there was this special character that was not letting the transaction go through. So if you see for this get request status, for our request ID, the fulfilled flag is true, and we got two random words. So this is how you get the random words. And this brings us to the end of the demo. I hope it was useful. Thank you for watching. Bye bye.